By the end of the first 3 minutes, the grand cosmic forge fell silent. The universe had expanded enough to cool past the point of nuclear fusion. The chaos settled, but a new problem arose. The universe was now a vast, glowing, blindingly thick fog. Even though the cosmos was filled with light, it was completely opaque. Because the temperature was still too hot for electrons to settle down and join the atomic nuclei, millions of free-floating electrons were buzzing around the plasma. Whenever a photon of light tried to travel through space, it instantly smashed into a free electron and ricochets wildly. Light was trapped in an endless cosmic pinball machine. The universe was a brilliant, glowing, white-hot soup, but no light could travel across it. It was a dark age of a completely different kind. How did the lights finally turn on? Let's find out. For 380,000 years, the universe remained trapped in this blinding, opaque state, a cosmic prison of light and electrons. But as space continued to stretch, it also continued to cool. Slowly, the temperature dropped from millions of degrees down to roughly 3,000 Kelvin. At this precise temperature, a cosmic miracle occurred. The high-energy environment calmed down enough for the free-floating electrons to finally slow down. Under the gentle pull of electromagnetism, they dropped into orbit around the waiting hydrogen and helium nuclei. The first stable, neutral atoms were born. This epoch is known as recombination. With the free electrons suddenly locked away inside atoms, the endless cosmic pinball game came to an abrupt halt. The highway of space was suddenly cleared. For the very first time since the dawn of time, photons of light were free to travel across the cosmos without smashing into anything. In a single, glorious moment, the blinding cosmic fog lifted. The universe became transparent. The light released in this moment was an intense, brilliant flash of orange-white radiation, the first light of creation, screaming across a newly opened void. But as the universe kept expanding over the next 13.8 billion years, the very fabric of space stretched. This expansion elongated those ancient light waves, shifting them out of the visible spectrum down into the infrared, and eventually into invisible microwaves. The first light of the universe didn't disappear. It became the cosmic microwave background, CMB, a faint, ghostly echo of the Big Bang that fills every cubic inch of space today. For billions of years, this echo traveled in silence, until 1964, when 2 radio astronomers in New Jersey, Arno Penzias and Robert Wilson, accidentally stumbled right into it. They were using a massive, ultra-sensitive horn antenna to listen to radio waves from the Milky Way. But no matter where they pointed the antenna, they kept picking up a persistent, annoying background hiss. It was a low, steady hum that never stopped day or night, summer or winter. Thinking it was a mechanical flaw, they inspected the giant antenna. What did they find? A pair of pigeons had nested inside the horn, coating the delicate equipment in what the scientists formally described as a white dielectric material. In plain English, pigeon droppings. They cleaned out the antenna, evicted the pigeons, and scrubbed down the metal. But when they turned the machine back on, the hiss was still there. What Penzias and Wilson didn't realize was that they hadn't found a glitch. They had found the holy grail of cosmology. They were listening to the actual thermal echo of the Big Bang. That annoying hiss was the oldest light in existence, degraded over 13.8 billion years into microwaves. It was the definitive, undeniable proof that our universe started from a hot, dense singularity. For their trouble and their cleanup crew duties, they were awarded the Nobel Prize in Physics. The CMB gave us a flawless map of where we came from, but it also unlocked a terrifying question. If the cosmic movie reel started with an expansion, how does it end? For decades, scientists thought gravity would eventually act like a cosmic brake pedal, slowing the universe's expansion down and perhaps even pulling it back together in a violent, big crunch. But in 1998, astronomers looking at distant, exploding stars made a discovery that sent shockwaves through the scientific community. The expansion of the universe isn't slowing down at all, it's speeding up. Driven by a mysterious, invisible pressure we call dark energy, the universe is tearing itself apart at an accelerating rate. And this leads us to the most widely accepted, chilling finale for our cosmos, the Big Freeze. Trillions of years from now, the universe will expand so much that distant galaxies will fly away from us faster than the speed of light, disappearing forever from our night sky. The night sky will go completely dark. One by one, stars will burn through their nuclear fuel and blink out like dying embers. Galaxies will become cosmic graveyards of cold, black holes, dead neutron stars, and frozen planets. Eventually, even those black holes will slowly evaporate through Hawking radiation over an unimaginable vastness of time. The universe will become a vast, cold, infinitely stretched void of nothingness. The temperature will plunge to absolute zero. No energy can be extracted. No changes can occur. Time itself will lose all meaning because nothing will ever happen again. It is a hauntingly beautiful realization. We live in a brief, extraordinarily lucky window of cosmic history. We exist in the sweet spot, long after the chaotic, blinding fury of the Big Bang, but long before the eternal, frozen dark of the Big Freeze. We are the universe's way of thinking, feeling, and looking back to wonder how it all began. From a microscopic singularity smaller than an atom to an infinite expanse of conscious minds, we are born of the Big Bang, journeying through the light into the great cosmic unknown, and that journey continues with every single one of us. Thank you for exploring the cosmos with me throughout this 3-part series. If this journey blew your mind, hit that subscribe button, leave a like, and share your thoughts in the comments below. What part of the cosmic story fascinates you the most? Until our paths cross again in the infinite expanse, keep exploring.